Hello there everyone, this is Zenith and today we'll be doing Physics MCQ Paper 1 9702. This is of October-November 2023 and let's get started. Question number 1. What is a reasonable estimate of the cross-sectional area of the wire in a paperclip? Alright, now again this is an estimate question. Usually for estimate questions your knowledge about estimates and basically general knowledge must be very clear. Now, if you're not sure exactly what is the cross-sectional area of a paperclip, it is approximately just like the cross-sectional area of your pencil nib. It would be a bit difficult to imagine, but the thickness of your pencil nib is approximately the same size of the wire in a paperclip. But even if you won't know this kind of comparison, you could try doing reverse and instead calculate the lengths from the given values over here. All right. So, what could be a reasonable length, right? Thickness of the wire in a paperclip. They're asking about over here cross sectional area. We assume it's a circle. What could be its diameter, right? Now we assume that its diameter should be 1 millimeter, which is a reasonable estimate because if you think about it, otherwise 1 centimeter is not a reasonable size for a wire. That's too thick for a wire. So around 1-2 millimeters is a reasonable size for a wire and paperclip. So now let's do the calculation, right? So it is first option 1 multiplied by 10 to the power minus 3, which if you have to convert it, the best unit that you could convert to is millimeters, because that would give us a nice idea. So that would mean first of all that you're going to take root, because we assume that all of these will be just diameter squared. No need to go into complex formulas, just under root it and get the basic length, because we're working with very coarse values over here. So it does not matter the precision. So in this case 10 raised to power minus 3 under root, that would give you 0.03 meters, which if you then multiply by 10, then multiply by 100 to get into millimeters, you would get 31 millimeters, which is a lot. 31 millimeter does not make sense. We are looking for 1 millimeter. Similarly, we can go for option B, C, and D. If you go for option B, let's see, 8 multiplied by 10 to the power minus 5 root, that would be 0.08 meters. Again, multiply it by 1000, so you would get 8 millimeters, which again doesn't make sense. 1 millimeter is what we're going for. And just to keep a realistic idea of what scale you're going for, have a ruler beside you so that you can keep comparing the values side by side. Then we can go for option C, 8 multiplied by 10 to the power minus 7. That would give us 0.00089. Again, multiply by 1000. 1, 2, 3, 4. You would get around 0.89 millimeters. And that makes sense because that's within the 1 millimeter range that we put inside. Therefore, option C looks like the most reasonable answer. Question 2. Which quantity is not an SI based quantity? Alright, mass is, temperature is, and time is. Obviously, over here, charge is not the SI based quantity. So, option A is correct for question 2. Question 3. A student determines the acceleration of free fall by using a small metal ball as shown. When the switch S is opened, the ball is released from an electromagnet and an electronic timer is started. The ball then falls vertically downwards. Timer stops when the ball hits the trapdoor. The student measures the distance PQ or PQ between the electromagnet and the trapdoor. This distance and the reading on the timer are then used to calculate the acceleration of free fall. Right. So over here, they are measuring the time taken and the height fallen. So they are using it to calculate acceleration of free fall, which is basically g. So first of all, what exactly are they asking us in this question? They're asking us about whether it would be a random error or a systematic error. How can we know it's a random error or systematic error? First of all, we are not using any human method in this question. We are using electronic devices. All of it is electronically calibrated. Usually for these questions, you would also have another method in which you throw a ball from a certain height, and that could introduce some random errors because, of course, our hand would be wobbling up and down, and that would introduce some uncertainty, most importantly, random errors. But in this case, you are always using the same electronic timer, which is always again using the electromagnet. So all of this is just working in a circuit. All you have to do is to control this switch. So this could introduce some sort of fixed errors. Those fixed errors in this case would be systematic errors. If they would have asked, or if they would have said that there's a human hand being involved in this method, that means that there could be some random errors. But in this case, it could be a systematic error. So option A and B are automatically cancelled. Now let's see. Option C says the systematic error can be reduced by adding the diameter of the ball to the distance PQ, and option D says systematic error can be reduced by subtracting the diameter of the ball from the distance PQ. Right. So another property now they're asking us over here is that the center of the diameter. They're asking us over here the diameter. Why are they exactly asking us the diameter over here? Is because when the metal ball falls from the height, it doesn't exactly fall from P to Q. When you're working with acceleration of free fall, you are working with where its center of mass, center of gravity is located, because that's where most of the weight supposedly acts. Therefore, it means that you are not throwing the ball from exactly P. Instead, you're throwing it from a bit height below P, because the center of weight or the center of gravity of the ball is not at the point P, it is below point P. Similarly, you are reaching the the timer exactly stops when the ball hits the trapdoor. So this is another fault over here. The question mentions that as soon as the trapdoor is touched by the ball, the electronic timer stops. That is again a bit incorrect. That means the ball supposedly reaches over here. Again, its center of gravity is not exactly at Q. It is a bit height above Q, right? So this a bit height above Q is in fact the radius, and it of course makes sense. This is the trapdoor, and the question says as soon as the ball touches it, the electronic timer stops. If you're going to find the center of mass, it is just a distance of one radius. Similarly, if you look at the top part of the electromagnet and the ball, the distance from the bottom of the electromagnet and to the center of the ball, assuming it's a uniform ball, is again r. And r plus r gives you the diameter. Therefore, you're going to subtract the diameter of the ball from the distance PQ, because the actual height fallen by the ball, or the center of gravity of the ball, is lesser than the total height PQ. Therefore, option D is correct. Option C obviously won't be correct. If you're adding the diameter, you're just increasing the distance. That means you're just starting it from here and here, which is extra distance that the ball really did not cover, in fact. So you have to subtract from the height which the ball has covered it. Therefore, you're going to subtract the diameter. So option D for this question is correct. Question 4. The diagram shows two coplanar forces P and Q drawn to scale. Forces R is given by R is equals to Q minus P. Which diagram represents R? Right, now do not rush to just make a triangle with these forces and then pick the answer, because they've given us that R is equals to Q minus P. Alright, very important over here. Q, they're considering it positive, but with P you have a minus, which means that it is going to flip its direction. So P would be like this, minus P, because that is R. Now you are going to make the vector triangle. So this was going to be over here, P like this, minus P, and then you can complete it from head to tail rule to get this as your resultant. And therefore, option C is the correct answer. Question 5. A parachutist falls from a stationary balloon at time t equals to 0. The velocity time graph for the parachutist from time t equals to 0 until the time when he is just above the ground is shown. Which graph best shows the variation with time of the acceleration of the parachutist? Alright, so now they're asking us to convert this graph from a velocity time graph to an acceleration time graph. This should be relatively easy. Look at the gradient, because in this case we are working with the gradient. That gradient is the thing which represents the acceleration in this case. For the first part, let's concern ourselves with just the first part, the curved part. We can see that the acceleration is decreasing. How? Because the gradient of the graph initially over here is decreasing. So we're going to look for that quantity, right? So we have gradient decreasing here, we have gradient decreasing here, we have gradient decreasing in all of the options. But look again, initially we know that the acceleration of free fall is 9.81 for all the objects, right? So it must be a positive acceleration initially. Therefore, option C and D are automatically cancelled. Over here, it is showing us that the acceleration is negative, while over here, the gradient is initially positive 9.81. So it could be either option A or option B. Now let's look at the second part. The second part is just the constant velocity part, so nothing special goes on over here. But next, we have this very steep curve between Q and R. Now, another thing to notice here is that the curve or the steepness of this curve is less than the steepness of this curve. Over here, acceleration is decreasing at a longer time period, whereas acceleration over here is decreasing in a shorter time period. And another important thing, the gradient is very high over here. The gradient is a large value here. That means the acceleration must also be larger than the initial acceleration over here. That means it must drop to a lower value than it was initially. So it looks like option B. And of course, then it would return all the way back to the 0, because between R and S it was constant velocity. Therefore, option B is correct. So all you had to do was to look at the gradients and see which one is more steeper. Do not do the mistake of selecting accidentally option A, because it makes sense and it is correct, but you have to look at the fact that the gradient here is much steeper. It just can't go to the same negative value as it was initially. So option B is correct. Question 6. A projectile is fired from point P with velocity v at an angle theta to the horizontal. It lands at point Q, a horizontal distance r from P. R from P after time t. The acceleration of free fall is g. Air resistance is negligible. Which equation is correct? So in all of these questions, they're asking us equation of r, or basically the horizontal distance. S is equals to ut plus 1 by 2 at square, one of the equations of motion which we can use. Now we know under no air resistance, we can completely ignore the second part of this equation, because horizontally there is constant velocity, hence there is no acceleration. What you have left behind is S is equals to ut. S in this case is r. What is u in this case? U is not just v in this case, because v is the overall speed. You need to find the horizontal component in this case. The horizontal component would be v cos theta, and time is just time t. If you just write it in a better form, it would be vt cos theta. Hence, option A is the correct answer. Question 7. Man stands in a lift that is accelerating vertically downwards as shown. Which statement describes the forces exerted by the man on the floor? Right. So, is it equal to the weight of the man? Is it greater than the force exerted by the floor on the man? Is it less than the force exerted by the floor on the man? Is it less than the weight of the man itself? So, the best way we can approach this is by using resultant forces. All right. In any of the complex scenarios, it is best that you draw out all of the forces acting on the object, just to clarify what is going on. Right. So, this is the platform over here, the base of the elevator. Let's take it over here. Now we know weight is acting downwards. That's the man's weight. And then we have a normal force acting as well, which is exerted, of course, by the floor on the man. And they have said to us that the resultant force F net is downwards. So with this, we can construct a pretty reasonable equation that F net is equals to W minus the normal force. Why W minus the normal force? Because we assume that W is greater. If W weight is not greater than the normal force over here, then the acceleration would be either upwards or there would be no acceleration at all. But that's the case if W equals to the normal force. Weight will always stay constant. We know that for sure. Why? Because W is mg. Normal force will of course vary. And then F net force is basically ma. We can then rearrange it to take the normal force over here and then have mg minus ma. Now, why am I considering myself with this normal force? This normal force over here is the force which varies, right? It cannot be the weight of the man itself, which can vary because the weight of the object remains constant if its mass is constant. So we do not have to fiddle with the weight at all. What we can work with is the normal force. And normal force is the consequence of Newton's third law. Why? Because equal and opposite forces have to act. If there would be no normal force acting by the floor on the man would just fall through the floor. Therefore, the normal force has to equal the weight of the man. But in this case, scenarios change. I'm just going to finally simplify it. We can just take the mass common, so it would be G minus A. Now, from this, we can have an interesting conclusion. The normal force is the force exerted by the man on the floor, because even though normal we are saying is the force exerted by the floor on the man also has to exert this equal and opposite force onto the floor, right? So if this normal force is being exerted by the floor, the man also has to exert this same force. If not, he's just going to fall through the floor. And also because it's a consequence of Newton's third law, equal and opposite forces act, action, reaction, force pairs. Therefore, we are going to associate this normal force with the force exerted by the man on the floor. And over here, it is clear that there is some acceleration. If there would be no acceleration, if acceleration is zero, the normal force would equal weight. But in this case, acceleration is there. That means it would subtract from g. Suppose g is 9.81 and a is suppose 9. Subtract it, you get m into 0.81, which means this normal force has decreased a lot than the weight. And therefore, we can say that the normal force will be lesser than the weight. And hence, we can say that the force exerted by the man on the floor will be lesser than the weight. Now we can go to the options. Firstly, it is equal to the weight of the man. That's absolutely wrong from the very first point. If it would be equal, there would be no net force. Option B, it is greater than the force exerted by the floor on the man. No. Option D is what we are looking for, that it is less than the weight of the man itself. Over here, we just concluded that this normal force or this force exerted by the man on the floor is less than the weight of the man. So option D is correct. Rest of the options, of course, do not correspond to our equations, which we have just calculated. Question 8. A ball of mass 200 grams is thrown horizontally with a speed 20 meters per second against a vertical wall. The ball is in contact with the wall for a time 0.10 seconds before rebounding back along its original path with a speed of 10 meters per second. What is the average force exerted by the wall on the ball during the collision? Right. So to calculate the resultant force acting on the ball, that would be F delta mv over the time. Now note over here, we're calculating the force exerted on the ball. So initial mass was 200, 200 divided by 1000, that would be 0.2 kg, and the final minus initial velocity. So final over here would be minus 10. Very important, because the ball was going with 20 meter per second, but then the direction changed, and hence this should be minus 10 meter per second. Direction is very important. The final minus initial, minus 20 meter per second over the time 0.10 second. Calculate this, 0.2 into minus 10 minus 20 over 0.1, that would give us minus 60 newtons acting on the ball, which is equals to the force exerted by the ball. So the wall is exerting 60 newtons, and it would be minus 60 newtons in terms of the ball because the force is acting in opposite direction of its velocity, right? But of course, equal and opposite forces, so minus 60 newtons is acting on the ball, then the ball must be exerting 60 newtons. So option B is correct. Question 9. In an experiment, a metal ball is dropped into a viscous liquid. The terminal velocity of the ball in the liquid is measured. The experiment is repeated 4 times. For each repeat, a change is made to the one of the following. 1. Density of the metal ball. 2. Height from which the ball is dropped. 3. The density of the liquid. 4. The depth of the liquid. Which two changes separately affect the terminal velocity of the ball in the liquid? Right. So when we have the ball falling through liquid, we have two forces acting on it. One is the weight and one is the upthrust. If these both equal, then you get your terminal velocity, right? So we need to concern ourselves with these two forces. What is upthrust? Upthrust is the density of the liquid into gravitational force into the volume of the ball that is submerged under the liquid. So let's see one by one. Density of the metal of the ball. Yes, this can affect because density is equals to mass over volume. If you're going to vary density, either increase it or decrease it, that will change the volume. All right, that will definitely change the volume. And volume is also being used in the upthrust over here. So this force would be affected, and that would of course also affect the constant velocity that the ball will reach. Similarly, height from which the ball is dropped, that does not make a difference because again in the liquid only these two forces would be acting, upthrust and weight. So this won't make much difference. The density of the liquid, of course that makes sense because the density of the liquid is being used in the upthrust. Depth of the liquid, no, because that does not affect the two forces which are acting over here. Correct options are 1 and 3. So option B is correct. Question 10. Two objects move towards each other along the same straight line. After colliding, the two objects must stick together and are stationary. Which statement must be correct? Right. The total kinetic energy of the two objects does not change during collision. Of course, it changes. They basically collide. They're going with some velocity, right? And after that, they're just stationary. So the overall velocity is just zero. Velocity changed, kinetic energy would have changed. Option A is wrong. Option B, the total momentum of the two objects before the collision is zero. That's right, because it has been said that after the collision, both of the balls are stationary. Therefore, the overall momentum or the total momentum will be zero. So, initial momentum before the collision must also be zero. So, option B is correct. Option C, the two objects have equal mass. We cannot exactly say about this because we do not know with what velocity component they were traveling. So, it's not only dependent on mass, it's also dependent on the velocity. We cannot just decide that from the mass that the two objects stick together and are stationary. So it cannot be correct all the time. Option C would be wrong. Option D, the two objects have the same speed before the collision. Again, we cannot say about that because we do not know anything about the mass. Right. So option B is correct. Question 11. A minimum torque of 20 Newton meter must be applied to the lid of the jar for it to open. The radius of the lid is 4 centimeter. What's the minimum force F that must act on each side of the lid in order to open it? Right, so this is torque of a couple we're dealing with over here. Torque of a couple is what? Torque of the couple is one of the forces multiplied with the perpendicular distance. In this case, perpendicular distance is 4 centimeters plus 4 centimeters. That gives us this overall distance or perpendicular distance of 8 centimeters. So we have the torque that is 20 Newton meter. We need the force. Make sure you convert your 8 centimeters into meters. So force would be 8 divided by 100, 0.08 divided by 20. Force would be 250 newtons, and this is one of the forces. The minimum force F over here is option C, 250 newtons. Question 12. A uniform bar of length L and weight W rests horizontally on two supports X and Y. Support X exerts a vertical force Rx at a distance of L6, L over 6 from one end of the bar. Support Y exerts a vertical force Ry at the other end of the bar. The bar is in equilibrium. What is the ratio Rx over Ry? Right, so we need to now form a system of equations to solve this question. The very first thing, because they're asking us about ratio of Rx over Ry. Very important over here. It's just the ratio, so we don't need to get its exact values. And we can't even get the exact values because of the L over here. Right. So they're asking us to find ratio of Rx over I. From a combination of four unknown variables here, they're asking us to boil it down, bring it down to just ratio of two variables. That means we need to form equations in such a way that we cancel out the variable L and W. Right. So let's look at each of these supports separately. Now, whenever you are having two supports or two pivots and forces acting on them, to simplify stuff, take one of the pivots and work with that pivot first. So the moments according to pivot, right? What is moment? Moment is force applied at a perpendicular distance from a pivot. In this case, let's first look at support X. So according to support X, there must be equilibrium, and according to support Y also, there must be equilibrium. So from the perspective of support X, Rx would have no effect because it is directly upon support X. So we ignore Rx. Right. Now we have to look at the other things over here. So let's just erase this. So we see W is acting at some distance, but what distance? We do not know that. Well, we know that this is a uniform bar. That means this distance from the edge to here would be L by 2. And we have L by 6 given over here. To find this length here, that would be L by 2 minus L by 6. You can even calculate in your calculator. Just suppose L is just 1 by 3. So 1 by 2. So 1 by 2 minus 1 by 6. That gives you L by 3. So this distance here is L by 3. Similarly, we can see that there is force Ry. From the perspective of support X, it is acting at a distance. Therefore, it will also cause some moment. But we need to know what is the distance Ry is acting at. So we know again that this length here to here is L by 2. So uniform bar, W is acting exactly at the center. So this length over here is L by 2. So L by 2 plus L by 3. L by 2 plus L by 3 would give us the distance of Ry from support X. So L by 2 plus L by 3, that is 1 by 2 plus 1 by 3, and that would give us 5 by 6. Now we can form finally our first equation. Right. So anti-clockwise moments must equal clockwise moments, first of all, from the perspective of support X. Right. That means L by 3 into W must equal Ry into 5 by 6. 5L by 6, yes. 5L by 6. Next, we just need to simplify it. As I said, we need to eliminate W in this case. So we're going to make W the subject, which so that we can just substitute it to the second equation, which we will form in a minute. All right. So this would be going over here 3 by L multiplied with Ry multiplied with 5L by 6. L cancels out and we are left behind with 3 into 5 by 6. That would give us 5 by 2 Ry. W is equals to 5 by 2 Ry. Now, this is very important. Now we need to find a second equation in which we can substitute W and basically get rid of W. Right, so now let's look at support Y. From the perspective of support Y, Ry has no effect. There is no moment caused by Ry. But Rx has and W has. W we know is acting at a distance of half of the length. That means it would be L2 into W, one of the moments. At what distance is Rx acting? So that would be L2 plus L over 3. That would again be 5L over 6 multiplied with Rx. Now we see W has been over here used, so we can substitute that value of W over here. That would be L by 2 into 5 by 2 Ry equals to 5L by 6 into Rx. We're almost there. We just need to cancel out L in this case. So L we can just directly cancel out. And then you just need to simplify it. So that would be 5 Ry over 2 into 2, 4. And over here we would have 5 by 6 Rx. So Ry would equal Rx into 2 by 3. Remember, we need to get it into the ratio of Rx over Ry. All right. So 3 goes over the numerator over here. 2 goes denominator. Rx over Ry goes into the denominator to the other side. So Rx over Ry equals 3 by 2. Look here, option A is correct. 3 by 2. Question 13. A type of firework is made by connecting two rockets facing in opposite directions to a rod as shown. The rod is attached to a frictionless pivot so the firework can rotate in a vertical plane. Firework has weight W. The pivot exerts force R on the rod that is equal and opposite to weight W. Right, so W and R, they're equal and opposite. Each rocket exerts a force of magnitude F. So these F are also equal on the rod at a perpendicular distance D from the pivot. The forces exerted by the rockets are always in opposite directions. Alright. As distance is negligible, which statement is correct? Right, let's see. The firework is in equilibrium because resultant force acting on it is 0. Well, that is half the truth. Resultant force acting on this rocket is in fact 0. That's right. But you have these forces over here. And these forces over here are acting at a perpendicular distance. They are literally giving us the hints over here that these are two equal forces that are always acting in opposite directions. So the line of actions are never going to meet each other. Most importantly, there's a perpendicular distance between them. This means this will form torque of a couple. There will be some resultant torque. Therefore, it is not in equilibrium at all. The firework is not in equilibrium because resultant force acting on it is not 0. Well, no, we are specifically going with torque over here. It's a matter of the torque here because the torque produced by these F forces is there and it's not 0. Option D in this case would be correct. Question 14. An object of weight W is suspended from a Newton meter. When the object is completely immersed in water, the Newton meter reads P. When the object is completely immersed in oil, the Newton meter reads Q. What's the ratio of density of oil over density of water? All right. So Q and P are some forces, right? The force would be upwards. Why? Because weight is one downward force, up thrust is one of the forces. Now the Newton meter has to pull upwards with some force that would keep this cube or this basically weight stationary. Similarly is the case with the force Q and in the oil. Therefore, we can say upward forces must equal the downward forces in order for this weight to be stationary. All right. So we can say the downward forces weight must equal the upward forces P plus the upthrust. Upthrust in this case would be rho GV of density. Let's take PW into G into V. Similarly, we can then rewrite this as PW minus P is equals to PW G V. Right. Then we can do the same thing with Q. So again, W would be same. W is equals to Q plus density of oil, which we do not know, PQ plus G into V. That would be W minus Q is equals to density of oil Q into G into V. And basically now they're asking us the ratio. Now in this case, we can just cancel G and W, G and V from both of the equations because that will remain same. Volume of the object remains same. What we are left behind is W minus Q is equals to PQ. and W minus P is equals to PW. Should be obvious from here. Density of oil is PQ over PW. That's now also equals to, because we have just said over here, PQ is equals to W minus Q, with PW being W minus P. There you go. That means W minus Q over W minus P is the ratio. That would be option D. Question 15. A crate of mass 50 kg is pushed a distance of 6 meters along a horizontal surface against a constant resistive force of 70 Newton. The crate moves at a constant speed. It is then lifted at a constant speed through a vertical distance of 1.2 meters back onto the lorry. What is the total work done in the process? Alright, so we have the crate 50 kg. It's a constant resistive force acting on it of 70 Newton meters, 70 newtons, and it is moved, right? It is moved through a distance of 6 meters, right? After which it is picked up through a vertical distance. So you have work done against gravity over here and work done against the frictional forces. Now they have said over here an important thing to note: constant speed. Constant speed means that the forward force acting on the crate will also be 70 newtons. Equal and balanced forces, which will be the thing that will give you constant speed. So we have work done that is equals to FD plus mgh. Why? Because against the gravitational pull, we're also doing some work. Force in this case is 70, distance is 6, plus that with 50 kg into 9.81 into height, that would be 1.2 meters. Let's calculate. That would 70 into 6 plus 50 into 9.81 into 1.2, that would give us 1008.6, approximately equal to 1000 joules. That would be option D. Question 16. The input power to a television is P in. The useful sound and light energy emitted by the television is P out. What's the efficiency of the television? Efficiency is said as the useful over the total. Total in this case is the P in, and the useful is P out over here. They have literally said over here useful sound is P out. So P out must be the useful on top. P in is the total. Option A is correct. Question 17. A builder holding a brick of mass 3000 grams drops the brick onto his foot. What's the reasonable estimate for the change in GPE of the brick? Again, it's another estimate question. For this, your estimates must be good. It's actually one of the estimates that you must remember, that the height of an adult person is 2 meters. Now we can assume that the man was holding it, right, from the ground at a distance of 1 meter. We can assume that he was holding with the arm position just halfway through. That would be 1 meter, right? So the brick falls a distance of 1 meter, and its mass, by the way, is not 3000 grams, but you need to convert it to kilograms before anything else. The kilograms. Now you can calculate the, so GP in this case would be mgh. So P into 9.81 in 1 meter, that would give you approximately 29.43, which is the closest answer to option A, that is 30 joules. In fact, if you even suppose that he was holding the brick above his head, which is possible because we cannot tell, we could also then have taken 3 into 2 into 9.81, and that would again give us 58.86. And you can see 58.86 joules is again closer to option A than rest of the options. But the important thing here is that he was holding the brick and it fell on his foot. That means only a distance of 2 meters at max would be covered. Do not go into thinking that he was standing on a house and then he threw the brick all the way from the top of a house or a building onto the ground. That distance would of course be a lot. That is wrong. The brick fell from his hands to his foot. Now you can assume how far or how high could he hold his hands to throw the brick. That could be at max 2 meters, at minimum 1 meter, because he could have held it at between or near to his waist, equal to the height of its waist. Therefore, 30 joules, option A is correct for question 17. Question 18. An elastic cord of unstretched total length 16 centimeter and cross-sectional area 2 into 10 to the power minus 6 meter square is held horizontally by two smooth planes at a distance of 8 centimeters apart. The cord obeys Hooke's law. A load of mass of 0.4 kg is suspended centrally on the cord. The angle between the two sides of the cord supporting the load is 60 degrees. What's the Young modulus of the material? All right. So Young modulus E is equals to stress over strain. So now we need to calculate stress and strain separately. Let us look at what is stress first of all. Stress is force per unit area. We know what's the area. The area is given to us cross-sectional area. That is 2 multiplied by 10 to the power minus 6. Force we do not know. Why we do not know? Because we can't just say force over here, by the way, is the tension in these cords. So we have two tension in these cords because they're holding on this mass. So you can see if you just multiply mass 0.4 kg with 9.81, that will not give you the force. You need to calculate the tension or that force over here in this case. So get yourself a vector diagram. You have mass of 0.4 kg. And then you have two tension forces. And you have angle of 60 in the middle, right? So if you're going to simplify this, 60, by the way, that would half into 30, 30 here, and 30 here. So if you tilt it sideways, right, you can see that this component over here, this R which you're looking for, resultant, that is the total force acted on. And then only we can find the tension in this case. So the thing is, we need to find tension because that tension is the force that is acting on the cord. That tension would be the horizontal component of this tension plus the horizontal component of this tension. If you simplify it into its component vectors, that would be 0.4 kg. Let's just directly go for the tension into 9.81 is equals to 2t cos 30. Why did I take 2t cos 30? Because one of its horizontal component goes here and one of its horizontal component goes here. Both of them act along the same vertical line. That is basically your R. So 2t cos 30. T cos 30 is understood because 30 degrees is between this base line and the T. If you just bring it to the side like this, tension 30 is over here. This obviously over here is the horizontal component. Therefore, you would use T cos 30 and you would multiply both of it by 2 because that is the opposite R acting to stop the mass from falling. So you've got this equation, now you simplify it. 0.4 into 9.81 is equals to 2g cos 30 degrees. And you would get your force as 2.2655 newtons. That should be enough. Right, so that would be tension or the force acting in the cord 2.2655 over 2 multiplied by 10 to the power minus 6. Make sure units are same. In this case, they are same. So we're just going to directly divide them. And we will get our answer as 1.13 multiplied by 10 to the power 6. That is the stress, in this case, pascals. That is the stress. Now we need to calculate the strain. Right. What will be the strain? Strain is the extension over the total length. What was the initial total length? Initial total length is not just 8 centimeters. Consider this part of the cord as well. That is also 8 centimeters. So 8 plus 8, that would be 16. Now over here, things have changed. You have 8 centimeters. You have 8 centimeters here as well. And this is also 8 centimeters. The total is 8 plus 8 plus 8. That would be 24 minus 16. Because you're finding the extension. Extension is the final length minus the original length, that would be 24 minus 16 over 16, that would be zero point 0.5, that is the strain. We've got stress, we have got strain, so we can now get back to calculating the Young modulus. 1.1 multiplied by 10 to the power 6 pascals over zero point 0.5. 1.13 in fact multiplied by 10 to the power 6 over zero point 0.5 gives us 2.26. That gives us 2.26 multiplied by 10 to the power 6, which equals to 2.3 multiplied by 10 to the power 6 pascals, and that is the Young modulus. So that is option C. Therefore, option C is correct. Question 19. The force extension graph shows plastic deformation of a sample of material. Which force extension graph shows plastic deformation of a sample of a material? Right. So what is plastic deformation first of all? Plastic deformation is when the object is stretched beyond its elastic limit and it does not return to its original length. If it returns to its original length, then that is not the plastic deformation, that is elastic deformation. There is nothing to do about Hooke's law over here because both of these plastic limits and the elastic limits lie usually above the Hooke's law. The thing is, elastic limit is the point up to which an object can be stretched and it can still return back to its original length. As long as an object is being stretched and it returns to its original length, we can say it has stretched elastically. But if it is being stretched and then it does not return to its original length, that means it has been stretched plastically. Irreversible stretch. In this case, we can see object was stretched and then it was released again. It came back to extension 0. That means there has been no change in length. Similarly is the case for B and C. If you look at D, it was stretched. Initial extension was 0. But then when it was released, it came back to something, let's say like 5 centimeter of extension was still there. It did not return back all the way to the original length. Its extension must have been 0, but it isn't. That means option D is correct. That shows the plastic deformation. Question 20. Two waves pass through a point P. The graph shows the variation with time t of the displacement s of the two waves at point P, what is the phase difference between the two waves at point P? Right. So the phase difference. The phase difference is denoted by the formula, that is the change or the difference in the distance displacement over 1 lambda multiplied by 360 or 2 pi if you're working with radians. So what exactly is lambda? Lambda will be the wavelength of the waves, and in this case we are working with two of the waves, right? Usually phase difference is also used within one of the waves to see the phase difference of the points, but we're working with two waves separately and we need to see the phase difference between the entire waves. So first thing you need to find is the wavelength, right? So wavelength of the big or the small one, do not be tricked into thinking that these have separate wavelengths. These in fact have the same wavelength. This lies on point one wavelength. One wavelength is from one crest to one crest, or from one trough to another trough. So we can take any of the two crests. In this case, one is here and the other one is at 8, 9. Other one is at 9. So subtract them and we get 8 seconds as one wavelength basically. You can do the same thing with the smaller wave as well. That would be 10 minus 2. That would again give you 8 seconds. Now, delta x. What is delta x? Basically, you need to find the difference between the two corresponding points on the separate waves. Just take any 2 points and you need to then find the difference between them. That will give you the distance between those 2 points, and that is basically what this delta x asks us for. Take any 2 points in this case, right? But it must be positive. The subtraction, when you're going to subtract it, that must be positive because we're working with positive angles over here. Right, so take any 2 points, but make sure they're corresponding points. Right, so let us take the crest because those are the easiest ones to identify. We have 1 point here and the corresponding point is over here on the second. We drop it down so we can see one is at 2 seconds, other one is at 1 seconds. So you subtract both of these, 2 seconds minus 1 seconds, multiply by 360. That will give you the angle. 2 minus 1 over 8 into 360. That gives you a phase difference of 45 degrees. Correct option is B. Question 21. Which row is correct for both progressive transfer waves and progressive longitudinal waves? Right. Transfer waves contain compression diffractions? No. They contain crest and troughs. So option is wrong. Can be polarized? Yes. Contain compression and diffraction for longitudinal? Yes, that's true. So option B is correct. Question 21. Question 22. A toy drone emits sound of constant frequency 800 Hz. The speed of the sound in the air is 330. The drone moves along a straight path directly towards the observer and then continues in a straight line directly away from the observer. The speed of the drone is constant. What is the velocity of the drone when the frequency of the sound heard by the observer is 850 Hz? Right. So first of all, let's work with the velocity. Right. Now we do not know, is the toy drone approaching it or is the toy drone leaving it? Right. We're just given this data. So we are going to use the Doppler equation. In this case, that would be the frequency observed equal to frequency of the source into the speed of the waves over v minus or plus minus vs, speed of the source. In this case, we're given 850 and fs here is 800. So we can see one thing clearly, that the frequency has increased. 330 and 330 down over here as well. And for now, we're just going to use plus because we do not know what is Vs. We do not know if the toy drone is approaching or leaving. We cannot tell. So for now, let's just take plus because negative could mess up our calculations. 800 into 330 over 330 plus V, that gives us minus 90.4. So we know the magnitude of the velocity is 19. How do we know it's going away from the observer or towards the observer? Well, one easy way is to know that 19, right? 19 is the magnitude of velocity. Well, the other way of identifying that whether it's going towards the observer or away from the observer is by looking at the frequency. If the toy drone is going towards the observer, right? So the source is moving towards the observer. That means all of the waves in front of the source would be squished together. The wavelength would decrease and therefore the frequency would increase. Whereas if the toy drone is going away from it, the source is moving away, right? That means again the front waves would be squished together, but the waves which are behind, they will have a further increasing gap. Wavelength behind the source would be greater, that means the frequency would drop. Over here we can see that the source's frequency is 800 and the observed frequency is 850. Frequency has been increased. That means the toy drone must be moving towards the observer because only then the waves of the sound in front of it will be squished. Thus, wavelength would decrease and frequency would increase. So it must be towards the observer. Therefore, option C is correct. Question 23. Which statement about electromagnetic waves in a vacuum is correct? Right. So the best thing you can do for this is first of all, note down all of the waves together. Because there is usually a chance of messing up in these questions. Why? Because of misconception between which wave comes first and which wave comes after in the order. So it's best if you list down the order first. It's very important. That would just overall increase your chances of making a mistake. So visible, ultra, just short names. Don't need to concern with the entire name, of course. Then you have X-ray, and then you have the gamma ray. Right. So frequency increases as you go down this. Frequency increases. And as you go from left to right, the wavelength that decreases. Now let's look at the options. Infrared waves have shorter wavelengths than visible light. No, because the infrared waves are behind visible light, must have a higher wavelength. So option is wrong. Option B, microwaves have longer wavelengths than radio waves. Let's see. Microwaves have longer wavelengths. No, they're in front of the radio waves. Therefore, they'll have lesser. See, ultraviolet waves have higher frequency than visible light waves. Ultraviolet is above visible light, its wavelength will be lesser, frequency would be more. Yes. Option C is therefore correct. Question 24. Vertically polarized microwaves are emitted from a source. The microwaves are detected by a receiver that is connected to a cathode ray oscilloscope. The waveform displayed on the screen of the CRO has an amplitude 2.6 centimeters. A metal wire grid that acts as a polarizing filter is now placed between the source and the receiver. The filter is oriented so that the plane of polarization of the transmitted wave is at an angle of 20 degrees to the vertical. Right. The distance between the source and the receiver is unchanged. The settings of the CRO are also unchanged. What is now the amplitude of the waveform displayed on the screen of the CRO? A lot of information. The only thing you need to note down is what are you working with, right? They're asking us about amplitude. What we are given or what we are going to work with is basically going to be intensity, because you have a polarizing filter over here. And whenever you're going to work with polarizing filters, you're always going to work with the formula or Malus's law, that is I transmitted, intensity transmitted is equals to the incident intensity cos square theta, right? So that is what you're going to work with. But in this case, there is no mention of intensity, but rather you have the amplitudes being mentioned everywhere. Therefore, you're going to work with this equation in terms of the amplitude. First of all, you need to find a relation with which you can correspond intensity with amplitude. So you should know this, that is amplitude is directly proportional, that the intensity is directly proportional to amplitude squared. In this case, that would mean intensity is equals to k a squared. For the sake of simplicity, we can just cancel out a, because eventually further in the workings as well, we will be cancelling out k. K is just a arbitrary constant that we keep. But what is important to know here, that I is equals to a square, right? So incident IT, first of all, do we know what is incident I? Do we know what is I incident? So we know that the waveform displayed on the screen of the CRO is having an amplitude of 2.6 from a source detected by receiver that is connected to a cathode ray. Distance what's source is setting on CRO. Also, what's the amplitude of waveform displayed on CRO? Let's see. So they have said to us that the waveform displayed on the screen of the CRO. CRO in this case would be over here, right? That's our receiver. Microwaves are detected by receiver that is connected to a cathode ray. Yes. So CRO will be connected to this. That would be the CRO over here. So initially the waveform displayed on the screen of CRO has an amplitude of 2.6 centimeters. All right. So I initial, let us just note it down. I initial, and that is considered when the polarizing filter is not there, right? It is just vertically polarized microwaves are emitted from a source. So there is no mention of a polarizing filter. So then after that, they put a polarizing filter. That means we already have the incident. The incident intensity we already have because we're given the amplitude. So I initial, right, or the IO in this case would be equal to amplitude squared. That would mean 2.6 centimeters squared. You do not have to worry about the units, because again, this is just a work of ratio, and in ratio, units rarely do ever matter. But especially in this case, the units will just cancel out eventually. So 6.76 centimeters. We have 6.76 centimeters as the initial IO, or the initial amplitude, right? So we can then put it, IT is equals to I initial or the I incident. That would be 6.76. That would be then multiplied with cos square 20 degrees, because now we have a polarizing filter in between. Now we're going to apply it into the equation. That would be then 6.76 into cos 20 squared that would be 5.9692. Right, we got the intensity transmitted, but we need to get the amplitude. Simply, IT in this case, right, was 5.9692. We need to work backwards to get our amplitude. Basically, just under root it, we get our answer as 2.44. Basically, 2.4 centimeters. D is correct. Question 25. In an experiment, a stationary wave is formed on a string stretched horizontally between two fixed points. Which statement about the experiment is correct? At certain times, the string between two nodes is horizontal with all points having zero displacement. Yes, this is true. Suppose this is the undisturbed position and suppose this is your stationary wave. Your stationary wave initially would look like this, then it would look like this, and then it would look like this straight on the undisturbed position until eventually, of course, it flips. You have this, and finally you have the peak again. You can see it eventually reaches this undisturbed position in which all the points are lying on that undisturbed position. So the string between two nodes is horizontal. That's true. Between two nodes is horizontal with all points having zero. Between two nodes, if we pick, eventually this string would reach the undisturbed position, all points having zero displacement. That is correct. True. Option B then. Each point on the string between two nodes has an oscillation of the same amplitude. That is wrong. Option, each point on the string between two antinodes has oscillation. If you take two antinodes, one antinode is here and one antinode is here. If you look over here, not all of the points have the same amplitude over here. Otherwise, it won't form a stationary wave. Similarly, the number of nodes is equal to the number of antinodes. You can literally work this out. If you have two nodes over here, just form any stationary wave. It does not matter, but just for the sake of explanation, suppose we have a stationary wave like this. Then count the number of nodes. You have 1, 2, 3, 4, 5 nodes. And then if you look at the antinodes, you have 1, 2, 3, 4. So of course it's not equal. Similarly, two adjacent antinodes oscillate in phase. That's wrong. This one is going up, this antinode, and this antinode over here is going down. They're completely out of phase or anti-phase in this case. So option D is also wrong. Option A is correct. Question 26. A musical organ produces notes by blowing air into a set of pipes that are open at one end and closed at the other. Right. So again, it's about stationary wave. We have closed at one end, that would be a node, and open at the other end. That means there must be an anti-node over here. Speed of the sound in the air in the pipes is 320 meter per second. What is the lowest frequency of the sound produced by a pipe of length 10 meters? Right. So to have the lowest frequency, you need to make such a stationary wave that would have the longest wavelength, right? So how low as a stationary wave can you go? A stationary wave could go like this, or a stationary wave could go as low as like this. If you go any below than that, then you can't call it a stationary wave. So we have a fixed point, right? So sketch one like this. That would be one of the progressive waves forming the stationary wave. And then we have the other one that would go like this. That is the lowest possible stationary wave that you can form in the pipe. You cannot form any lower stationary wave than that. You can call it the fundamental stationary wave. So we formed it like this. Now you just need to know what is the distance between a node and an antinode. This must be known, of course. So the distance between one node to an adjacent antinode basically equals to pi by 4, is equal to the wavelength divided by 4. Right. So then we can put it into the equation. F is equals to F lambda. 320 is equals to F into wavelength. So wavelength, we have lowest frequency of the sound produced by the pipe is 10 meters, right? So 10 meters is the total length over here, right? 10 meters is the total length equals to lambda by 4. Because we just figured this out, the lowest stationary wave will have lambda by 4 over here. That means lambda over here would be 40 meters. We have 40 meters, then back into the original equation, then 320 divided by 40 320 divided by 40, that would give us frequency as 8 hertz. So your option is option B. Question 27. In an experiment, water waves in a ripple tank are incident on a gap as shown. Some diffraction of the water waves is observed. Which change to the experiment would provide a better demonstration of the diffraction? Currently, you can see that the wavelength is very small and the gap is very big. That means you're going to have diffraction in this way. You're going to have the waves like this and a bit of bending on these sides. Very less pronounced diffraction. So now they're asking us which one would provide a better demonstration of diffraction. A better demonstration means that you want to show the diffraction in a much better way, more pronounced basically. Increasing the amplitude won't help. It's all about the wavelength. Again, frequency would, if you're increasing the frequency, that would just further lower the wavelength, which we do not want. Increase the wavelength of the waves, that's true, because the more is the lesser difference between the gap width and the wavelength, the better diffraction. Option C is correct, because as you make the wavelength greater and greater, it would eventually have the gap width. It would eventually be equal to the gap width. Therefore, option C is correct. Increase the width of the gap, that would just increase the further difference between the wavelength and the gap itself. That would just reduce the diffraction too. Option C is correct. Question 28. A light of wavelength lambda is emitted from 2 point sources R and S and falls onto a distant screen. At point P on the screen, the light intensity is 0. What could explain the 0 intensity at P? Right, so that means they're saying us that there is light reaching from here, point R, and from point S in such a way that there is 0 light intensity. 0 light intensity means amplitude must also be 0, right? That means the waves must be approaching in such a way. Suppose this is wave R and this is wave S. Suppose they're reaching in this way. If and only if they're reaching in this way to point P, then only we can say that the light intensity would be 0. Why? Because the amplitudes are equal and opposite. They are completely anti-phase. That means that the resultant wave that would form would just be a straight line. That means 0 amplitude, which means 0 intensity. So now let's look at the options one by one. Right? Suppose if we have our wave over here, the undisturbed position is over here like this. We have this point P and this is like the starting point. Let's suppose starting point is like this. So for both of them, we can take the same starting point. But what's important over here is the way the waves overlap. Suppose this is our wave R, right? Now they've asked us for option A, light from the two sources emitting 180 degrees out of phase. And the path difference is half lambda. So if the wave, right, the first wave is R, we don't need to touch that. We have to just fiddle with the second wave to bring out these changes. So if 180 degrees out of phase, that means that the wave of S must be like this, right? But most importantly, then they have said to us that it would have a path difference of half wavelength. That means it's going to be shifted half to the right. You can see it just overlaps. It just overlaps with the wave R. That means it constructively interferes here, and that's not what we want. We want complete destructive interference. Then we have option B, light from two sources emitted in phase and a path difference is lambda. Again, that won't make any change. If they are being emitted in phase, and even if they're having a whole difference of half lambda, that would still mean that they're overlapping. Same cases with option C. If you're emitting it 90 degrees in phase, that means it would start somewhere over here, the wave S. And again, it would overlap if you're having 1/2 a lambda or 1 lambda in fact. Now, if you look at option D, however, light from two sources is emitted in phase and the path difference is half lambda, right? So we started in phase. That means that S in phase would look like this, right? But now they've said to us that the path difference is half lambda. Hence, the wave would form in this way. The wave R, the wave S would form in this way, shifted half lambda to the right. And you can see that again over at point P over here, they approach in such a way that basically the amplitudes cancel out. The amplitudes are equal and opposite. They're completely anti-phase in this case. And therefore, option D is your most reliable option here. Option D makes sense. Option D is what gives us the complete destructive interference. So option D is correct. Question 29. A beam of red light of wavelength 720 nanometers is incident normally on a diffraction grating and produces a diffraction pattern on a screen placed parallel to the grating. The beam of red light is replaced with the beam of electromagnetic radiation of wavelength X, which is incident normally on the same diffraction grating. Third order maximum for the electromagnetic radiation is at the same position on the screen as the second order maximum for the red light. What is wavelength X? So basically what they're saying to us that for red light, this is your n maxima of 0th order, and then you have your n is equals to 2, which is your second order maxima. The second order maxima, and it has some angle theta, right? What the question is trying to say to you is that for another for another radiation X, it has n is equals to 0, but its the third order maxima is at the same position as of the red. That means that their angle must be equal. So for diffraction grating, you use the formula sine theta is equals to n lambda, right? So so the sine theta would be equal for both of them. That means you can simply make sine theta the subject. That would be n lambda over d, because we know sine theta that would be the same for both of them. So we can then just equate both of the wavelengths together. That would be sine theta. So n lambda of x over d, which is the distance between the slits, would be equal to the n lambda of red over d. Similarly, without any further calculation, you can just cancel out d, because number one, we are not given d, and number two, d will be the same for both of them. You can cancel them out. So you've got this. Now you can simply equate them together. The third order maxima is equal to the second order maxima of the red wavelength. So that would be x lambda, and for the second one, that would be 2 into 720 nanometers. So that would be 720 multiplied by 10 to the power minus 9 meters. So if you rearrange and solve for x, you would get that would be 3 into 2, then in 720 multiplied by 10 to the power minus 9. So you would get your answer as 480 multiplied by 10 to the power minus 10, or 480 nanometers. That's your answer. The wavelength of X is A, option A, 480 nanometers. Question 30. The current in the conductor is given by the equation shown. I equals to A and VQ. What is the letter N represent in this situation? Charge carried per charge carrier? No. Number of charges carried per unit area? No. Number of charge carriers per unit volume? Yes. Basically, number of charge carriers per unit volume. And if you cannot figure this out, the best way you can work with this is by knowing the units. This equation must be homogeneous first of all, which means that the signs must be same. The units must be same on the both sides. At the left side, you have current, which has the unit amps, and on the other side, you have area into N into V into Q. Area we know is meter square, and we do not know, right? You can just label this as X, and then you have V, meter second inverse. Then you have Q. Q is the charge, and charge is basically the current. Current is equals to current in this case equals to charge per unit time. So charge will be basically ampere second. Charge in this case would be ampere second. If you simplify this, right, you would have meter cube over second into X into your ampere second. Second cancel. You're left with meter per meter cube, and you're left with your ampere. So what will come in the middle? You definitely need to have the meter cubic in the denominator so that it can cancel out as well. So it is number of charge carriers per unit volume. So per unit volume, here you can see is the unit that we're going to take. Option C is the correct answer. In the circuit shown, question 31, the battery has an electromotive force EMF of 6 volts and a negligible internal resistance. The three resistors each have resistance R. The total power dissipated in the resistor network is 24 watts. Alright, so we know that the total power dissipated across this is 24 watts. What's the value of R? Right, so we know that P equals to IV. P is also equals to power dissipated is also equals to V square over R. In this case, we know what is power, that is 24 watts. V square also we know because that would be 6 volts. The whole potential difference across these 2 points will be 6 volt, 6 volts squared. And now we need to find R. What will be R? R in this case would be R effective, the effective resistance. That would mean, first of all, both of these are in parallel. So we are going to just apply them in inverse, right? So this one inverse for one of the branches, this the other inverse and whole inverse. In one of the branches we have these two R resistors, and that would be in series, so that would be added. That would be R plus R2R, and in the other branch we have just R, right? And then you do the inverse property on them. That means you're then going to calculate all of these as parallel. That would be your expression. This expression then goes over here, right? When you're going to calculate it, you're going to find your R. And R in this case would be 2.25 ohms, basically equals to 2.3. The correct answer is option D. Question 32. Which graph could show how the resistance R of a filament lamp varies with applied potential difference PD V as V is increased with the normal operating PD? Right. So we know one thing for sure, that filament lamp is not a ohmic resistor. If it would be, then the resistance would be constant, right? But in this case, resistance won't be constant at all. First of all, let us look at the graphs without any further calculation. Let's look at them at face value. The first thing you should do whenever you have a graph question is to look at it at the face value and identify those graphs which upright do not make any sense at all. There would be some options which do not make any sense at all, and you can easily spot them out without calculation. Let's see. A does not really make a bit, it looks like an option. So let's look at B. Now, B does not look like an option. Why? Because can you notice this? R is 0. Resistance is a property that cannot be 0 for a lamp. It is an internal property basically. Can't just say that the resistance would be 0. Otherwise, the lamp in fact would break because there would be such a high current flowing through it. So resistance won't drop to 0, of course. It can get low, but it would not drop to 0. So B is just wrong, because resistance is an internal property of the object itself. It can drop low, it can go as high as it can, but it won't really reach 0. So it can't be absolutely 0. Similarly, C looks wrong. Resistance won't be constant at all. Over here, we can see that there is no change in resistance. Resistance is being constant. That doesn't make sense. Resistance does not remain constant, right? Then you have option D, which looks a bit convincing. So now let's see from D and A which one makes most sense. First of all, let us see with the gradient. Gradient is R over V. All right. So from a typical equation of V equals to IR, V equals to IR, right? So I is equals to V over R. But in this case, we have inverse. That would mean 1 over I is equals to R over V, and that is the gradient, right? So that means the gradient is equals to 1 over I. Now we do know one thing, that as the current flows through the lamp, due to the filament and due to the material itself, the material heats up due to more charges flowing due to friction. So there is an increase in temperature. Increase in temperature will definitely increase the resistance, because as the temperature increases, the particles inside the wire or the material of the lamp will start vibrating. They will cause more obstruction for the current to flow. Therefore, current must decrease in this case. So let's relate it with this property. So over here we can see gradient is equals to 1 over I. That means as the gradient increases, current will decrease. Let's apply this logic to the graphs. So let us see over here. Over here we can see that the gradient, as a matter of fact, is decreasing. That means current will increase? No, that does not make sense. That should not be the case. So option A over here is correct, because over here gradient is being constant over here. But most importantly, yes, it's constant, so current flowing through it will also be constant. This option of course won't make sense. Number one, due to the fact that the gradient is decreasing, right? So the gradient is starting as -1, then it goes slowly to 0, and so on. So even if you put it in our calculator, like suppose starts from 1 over minus 2, that would be minus 0.5, all the way until it drops to 0. So option D, first of all, doesn't make any sense. Now, majority of you would also ask in this question that isn't the graph of a filament lamp a curve, right? A graph of filament lamp is typically a curve. The IV graph, which we usually say, is a curve. So why in this case we're choosing A? If you look carefully over here, they have said as V is increased to the normal operating PD. Normal operating PD is just the PD at which the filament lamp operates at its most efficiency, basically, right? Or it is basically, in simple terms, the PD at which the filament lamp is supposed to work reasonably, right? So it means this is the PD at which the lamp won't overheat much, but in fact, it would work at its best capability, best efficiency. Under these scenarios, the resistance, right, would linearly increase. There would be no curve in that because the temperature would increase very slightly at such operating PDs. Unless the PD is very high, only then the resistance would then start increasing in a unlinear, non-linear fashion. Then you would have the curve. But in this case, no. In this case, you're having gradient constant. That means current would be one thing that would be constant through this. So therefore, option A is correct. Option D is of course not correct because after we apply gradient is equals to 1 over I, that logic does not make sense at all. So in this way, option A is correct. Usually for such question, usually for filament lamp questions, always the options which show curves seem to be correct. But in this case specifically, we are just working with the fact that the PD is increased to the normal operating PD. So just a short point to remember, when the filament lamp is increased to its normal operating PD, assume that its temperature is going to increase very slowly and often very linearly, because the curve forms in either this way. So for a very short period, the normal operating PD is usually very small. For a very short period, the gradient does remain constant, right? But over very large PDs, then the resistance starts curving and there is a curve that forms. So if they talk about normal operating PD, just keep a lookout for such graphs. So option A is correct for question 32. Question 33. A piece of conducting putty is in the shape of a cylinder of length 60 millimeters and diameter 20 millimeter. The resistance between the ends of the cylinder is 20 ohms. What's the resistivity of the putty? Right. So resistance is equals to resistivity rho into L over A. Right. So we can just put in the formula. That would be 20 ohms equals to resistivity into the length 60 over 20, right? But make sure you also convert the units. So let's write this. Distance between the ends of the cylinder is 20 ohms, right? So we have then the resistivity which we need to calculate. L, we need to make sure we convert it to meters because all our workings is in meter. So 60 millimeter would be divided by 10 multiplied by 100. That would convert it to meters. And then make sure, first of all, this is a diameter. Do not just directly put it into a calculator. This is the diameter and we're working with the cross-sectional area, right? So the diameter of a cylinder, right? The cross-sectional area, we can assume it as a perfect circle. And then we can just find out the cross-sectional area as pi r square. So r would be then half the diameter. So 20 divided by 2 multiply by 10 into 10 because we need to 10 into 100 because we need to convert it to meters. Where all of this, and then you can put in the calculator. So that would be 60 over 1000, then pi whole squared 20 over 2 in 1000. Calculate and you would get your answer as 0.1, the resistivity. Therefore, option B is correct. Question 34. Which statement about the electromotive force EMF of a cell is always correct? Right, so let's see one by one. EMF is the energy converted from electrical to another forms in the cell. No, that's not correct. EMF is the energy provided by the cell per unit charge passing through it. Correct. That's correct. Basically, the definition of EMF is work done per unit charge in moving it throughout the circuit, right? Or in other words, basically energy transferred to the charge in moving it around the circuit. So option B is the most correct one for this question. Question 35. Kirchhoff's first and second laws are a consequence of the conservation of which two quantities? Alright, the first law is concerned with current, and the second law is concerned with the voltage, right? So now let us see. Current does not obviously correspond to mass, so option C and D will be wrong. Then you have option A and B, right? So conservation of resistance. Resistance already, as previously mentioned, is an internal property. It remains constant. There is nothing about preserving the resistance in this case. So of course, option B is wrong. In this case, we're talking about voltage, and voltage basically is concerned, as far as we know, with the energy, because the components can have any resistance. The components do have fixed resistance, right? If you're going to attach some components in a circuit, it does not matter what resistance they have, but what matters is how much PD is distributed to them, right? Or how is the PD distributed among each of the components. That is basically what the second law is concerned with, that the PD in a loop would be equal to the EMF, or the product of the resistances and the currents would be equal to the total PD. So in this case, it's not concerned with the resistance, but it's rather concerned with the potential difference, or the energy which is distributed between each component. So obviously it's energy, and second one is for the current it is charge. So option A is correct. Question 36. A circuit contains a cell of electromotive force E and internal resistance R connected to a resistor of resistance R. The current in the circuit is I. Which equation is correct? All right. Now, if you know the equation for such circuits where you have internal resistance, well and good. If you do not know, do not worry. Work with basic concepts, right? These two resistors R and R are in series, right? So what can we say about them? We can say that the IR, current across the PD across R, plus the PD across the other resistor will equal E. Why? Because this E has EMF, some of the PD is distributed to it, and some of the PD is distributed to it, just like a simple series circuit. And now you can rearrange it. Over here, we can see which one best fits. So let's look at first one. E equals to minus I, R equals to IR. Let's see in this way. So that would be E is equals to IR goes over there. It is indeed minus IR, plus minus IR is equals to IR, capital R. So that is correct. Option A is correct. So equation for this is option A. Question 37. A potential divider consists of two resistors of resistance R1 and R2 connected in series across a source of potential difference PD V in. The PD across R1 is V out. What changes to R1 and R2 will increase the value of V out? Right. To increase the value of V out, this one should be straight up forward understood, that the PD across R1, right, should increase. But they're talking about resistance in this case. So let us see. R1, resistance of R1 must be increased in whatsoever way. Only then the PD across it would increase. So we can just delete the options C and D from our minds. That is absolutely wrong. We do not need to decrease it. Must be doubled. Now what about R2? Well, if you double R2 as well, then the PD across this as well will increase. So that would provide no change in the ratio. Instead, what you want to do is to increase the PD across this and decrease the PD across the other resistor as much as you can in order to increase this V out. And therefore, to decrease the PD across R2, you need to half its resistance. Because V equals to IR, the PD across it is directly proportional to resistance. And B is correct. Question 38. Two alpha particles with the same kinetic energy are moving towards and then are deflected by gold nucleus. Which diagram could show the paths of the two alpha particles? Well, the first thing you need to know is that the gold nucleus is positively charged because it contains neutrons and protons. Neutrons have no charge at all, protons do have, and that's a positive charge. Similarly, alpha particles also have a positive charge because they are consisting of two neutrons and two protons. So now we know we have like charges over here. and like charges always repel. So you can see over here it's trying to attract it. That's wrong. In option C as well, they're trying to attract it. Wrong. Why are they being attracted? They should be repelled. So let's look at B and D. Right. Now over here in option B and D, it is showing which one is being repelled most and which one is being repelled less. Right. So let us look and see logically. The one which is passing much closer to the nucleus is being repelled lesser than the one which is being further away from it. That does not make any sense. You can also experience this with a magnet. Try at home, take two magnets. The more closer you try to push the same poles of the magnet, the greater the force of repulsion you'll feel, right? So, similarly, is the case with these like charges. The particle which is closer to the nucleus should be deflected more than the one which is farther away from it because the electric field, right, will be decreasing. So, the one which is farther away will have lesser deflection than the one which is closer to it. Option D in this case is correct. So question 39. Which nuclide is formed when 10,6 carbon undergoes beta plus decay or positron decay? Alright, so let's form our equation first of all. Carbon 10,6 undergoes some beta decay. We have some X over here, right? We need to only concern ourselves with the units first of all. Then later we can see if we have to concern ourselves with anything else. Alright, X plus positrons. So there are no neutrons at all. There are actually no neutrons, but it's beta positive, so positive charge, so there would be 1 in this case, 0 on top because it is the anti-particle of the beta negative. If beta negative is basically 0 minus 1, then the anti-particle of course will be beta positive, that would be 0 plus 1. That's a good way to remember them. So now we can see 10 is equals to what? Over here we can say this as A, we can say this as B. A plus 0. A would still be 10. You would have X with still 10. Whatever is the atom will still have 10. Then we look at the bottom, we have 6 equals to B plus 1. B in this case would be 5. So we get the number of protons as 5. Now let's compare. All of these are 6, 6, 7. So these options are wrong. Therefore, option C is correct because it has 10, 5. 10 as the total nucleons and the 5 as the number of protons as we had matched. Question 40. A particle, a particular hadron is composed of three quarks and has zero charge. What is a possible quark composition of the hadron? All right. So first of all, for such questions, it is always good that you note down what are the charges on the quarks. All right, just to avoid messing up. So I'm just going to write it in short form: UTC and SBD, basically. Up, top, charm, strange, down, bottom. Range down bottom, all of them have a charge of minus 1 by 3. Up top and charm have a charge of 2 by 3. And with this, you can then work out which one must be the correct one. So let's see for the first one. Down, down, strange, right? That would mean minus 1 by 3, minus 1 by 3, plus strange. So strange again is also minus 1 by 3, plus minus 1 by 3. So you would get minus 1 on this. And let's look for option B, up, down, strange. And they're asking us over here in the question zero charge. So we're working for a zero charge overall. So up, down, strange. Up is 2 by 3 plus minus down. Down is minus 1 by 3. And then you have again strange. Strange is minus 1 by 3. So 2 by 3 minus 1 by 3 minus 1 by 3. That gives you 0. Therefore, option B is your correct option. And this was October-November paper done. I hope you had enjoyed. If you did not understand any question, please do leave a comment. Please leave a like, share and subscribe. And I'll see you in the next video. Goodbye.